My name is Eduardo. I work on the Union AI team, and today we're going to be talking about caching of offloaded objects. Um, Quick agenda. First, we're going to talk real quick about what caching even means in flight context. Talk about caching semantics, how we represent some complex objects in flight, and finally, the feature that we are proposing called caching of offloaded objects. Open up for Q&A and put out some references because there's some interesting work there. So let's do it. First of all, what is caching? Straight up from the docs, caching is this ability that Flyte provides to cache the output of tasks. Okay, it's the output of task executions. It's not inputs. It's not like executions overall. It's like for specific tasks that we all know and love in Flyte. The rest is not so important. But then you have to think about like, okay, so how do you actually map to those outputs? You have to think about like how do you calculate the cache keys? So again, from the docs, cache keys are composed of project domain, cache version, task signature, and inputs. The important thing here for this feature really is inputs, because if you think about it, like Flyte allows you to pass in like from simple, primitives like integers and floats to the most complex object that you can come up with. And it's not super trivial to like come up with a representation of objects that allow for like good cacheability, so to speak. So let's talk about this real quick, just to refresh for people who have been using Flyte but haven't used cache tasks. This is how a cache task looks like. This is like very, very simple. We have the task decorator, and in it, if you want to use the cache, you should set the cache view to true and provide a version. This is like the minimal thing that you have to do. What this essentially means is that on the back end, now we know that for every call to this square task with this single parameter that you pass, like the integer, we're gonna cache the output. So we're gonna cache this integer, which is the square of the whatever input you pass in. Okay. So we're gonna build on this foundation, reaching that feature of like how do you go and cache crazy objects. But caching semantics, isn't that joke that there's only like three or two really tough problems in CS: caching and naming and like off by one values. So yeah, caching again from the docs. Task caching is useful when you know that you're gonna be executing a task with the same inputs. So let's talk about what is this notion of sameness that Flyte lets you work with. So right off the bat, one could ask, hey, are we caching values by reference or by value? What is the semantics that Flyte lets you use? So it turns out that it depends. For 99% of the objects, really, you are all caching by value. Like we do the simple thing, you just like provide the representation of the object that lets you assume that the caching by value is what's going to happen. But for some cases, and here I will pick our loved pandas data frames as an example of this. Um, it's not so easy to think about like how do you even represent a data frame, right? Like, what if you have a data frame that's like 1 petabyte of data? How does Flyte even know about that data frame? So Flyte has this great feature that at this point is a little bit underutilized, which is like we strive to be multi-language. And in order to do this, we have to basically map objects in native languages to the Flyte type system. Okay, so this conversion is what we're talking about here. So again, look at the question, how do we even represent data frames in the Flyte type system? Don't get too scared. This is just, some bit of code that will show why in the case of the data frames, the reference, the caching really can't really be by value by default. Remember, we map native values to Flyte types, and those Flyte types are what we call literals. And if you squint, forget about all this code, but just look at line 21. Look at what we're doing in line 21. We're returning an object of type literal that takes as inputs a schema, and the schema has a remote path and some type. So literally, like, we are not, when we have a pandas data frame that has to be mapped to a literal, Flyte never really knows about the content of the data frame. It just knows about this schema object, this reference to a remote path. That's how we represent data frames in the backend. The two Python values is not super important. It's just doing the reverse. Like we have this concept of type transformers, which I think we have a great talk on that we might have done some time ago. But anyways, go look at the docs. This idea that we use type transformers to map to Flyte values and go back to native values. In this case, it's Python, but not super important. But we finally get to the feature that we are proposing now. Like, we are going to let users basically override the behavior of these objects that are cached by reference by providing a hash. And we will not be super prescriptive about how you're going to go about hashing the objects. So here's how the syntax looks like. So let me walk through this example. Let's start from the bottom. We have a workflow that is composed of two tasks, right? We have a task called foo that produces a data frame, and a task called bar that takes the data frame as an input and is cached. Remember, we talked about how cache tasks look like. You have to set those two fields. Let's go back to the definition of foo. In foo, now take a look at the output of the task foo. Now we're saying that yes, you are returning a data frame, but we are saying that you're going to be hashing that data frame using some function that you're going to provide, and Flyte takes care of basically piping that hash value to the literal, so that Flyte can know about, hey, now when you're caching this, you're actually going to use the hash to provide a cache by value semantics to the caching system. And yeah, that is the feature we're working on. There's an RFC out. The first PR in FlyteKit is also out with most of what we talked about here. There's a lot of magic in the backend to provide a better experience, especially about when we talk about like how can we let the users know that they are misusing the cache in certain cases. Think of the case of like someone provides a task that takes a data frame as an input, and that task is cached. Like, if they do not override the hash, it's very likely that this task will not be cached at all. But again, open for questions. If you want to jump in the RFC too, feel free. It's RFC 1893. I put it in the references.
Hey, Eduardo, I have a question.
What's up?
Yeah, if you go back to the previous slide, this is, I like the syntax a lot. How does Flyte automatically analyze the fact that bar is taking the output of foo, and so will apply the type? to the
Yeah,
input?
that's a good question. Like for all intents and purposes, the compilation phase still knows about the literal type schema and can know about like how to match the types, just like a regular workflow. This is just like so that you can provide this extra bit of information about what is the hash of this object that you're producing, but
Right.
nothing else changes. Like it.
Right, and in this example, the bar df is annotated as just pd.dataframe. So how does that task know to hash the data frame, the incoming data frame?
Yeah, good question. So actually, it's when we go through when we transform the data frame into the literal, so that we can pipe into to the next task. It's that during that step that we basically add a value to the literal, saying, hey, actually the hash of this literal is X, which was calculated using this method that you provided. So it's not when the task is about to execute, it's when the task that produces the data that you want to override the hash that step happens.
Okay. Cool.
So essentially, we do it once. Like imagine you had like several calls to bar, and imagine bar had like multiple inputs. Like we only do it once.
Okay, cool, thanks.
Cool.
So remind us of the RFP number, Eduardo.
Oh, it's in the references. Yes.
Oh, there we go. 1893. So this is several people have been asking for this, or have been asking for the ability to do something like this. So this is coming from real live
user pain.
Yeah, real live user pain. They just wanted control over their own caching semantics. So this is it's an extensibility mechanism. It's relatively advanced feature when you're really into the cache semantics of your own objects and you want to take control over it. But if you have a dog in this fight, if you care about this, talk to Eduardo directly, or preferably comment on the RFP. Take a look at the PRs. If you want to contribute, we're open to ideas. But we're pretty excited about the ability to let people drive this themselves, because ultimately you know your data better than Flyte can know your data. So
exactly, that's kind of like the key of this feature. You can definitely explore an angle to your data that we cannot know.
Right. So we can only surmise the semantics from what we can read, but if you actually understand the semantics yourselves, you can take control of that with this hook. So pretty excited about that. Any other questions, or feel free to take those up directly with Eduardo afterwards.
Oh yeah, I have another one. Sorry. Does this syntax support grabbing, if you want to rely on the e tag of whatever blob store you're using? Does this support that as well, or is that another time for another?
Yeah, you notice that is a great question, and I know where you're coming from. We actually talked about using e tags in the RFC, so go read the docs, but the comment. But essentially, we wanted to take this first of all, e tags are associated with a specific resource. Okay, you can't reuse read tags between different resources. But the second reason, and I think it's a more noble one, is that you notice that we haven't really talked about how we store, or how we make better use of storage, like the blob storage, to implement this feature. It's completely separate. We're just talking about how objects that might be stored multiple times, they all have the same representation for Flyte's caching purposes. That's kind of we've been talking about it. it might be like a next phase of like, hey, can we even not pay this cost of like storing this thing multiple times, you know?
Thank you.
Yeah, good question.
Thank you, Eduardo.